Terraforming the Red Planet just got one step closer. First, we landed rovers on Mars. Then we launched the Mars Ingenuity helicopter. And now we've created oxygen on Mars for the very first time. It's all thanks to a high-tech instrument known as MOXIE, short for the Mars Oxygen In Situ Resource Utilization Experiment. It's a piece of machinery the size of a toaster built into the body of the Perseverance rover. It was designed to take carbon dioxide found in situ in the Martian atmosphere and convert it into oxygen. And now, 2 months into its mission with Perseverance, it succeeded. It managed to create about 5 grams of oxygen, which is about enough to sustain a Martian astronaut for 10 minutes. It may not sound like much, but according to Michael Hecht, the principal investigator for the MOXIE instrument, this is a game changer.
Anything involved with chemistry and energy requires oxygen, and we get it for free here on Earth. We do not get it for free on Mars. And so when we take a crew of astronauts to Mars someday, we will need an awful lot of oxygen to support that mission.
The atmosphere on Mars is 96% carbon dioxide, which makes it incredibly hostile to human life. If we want to send humans to live and work on Mars, we need to solve the oxygen problem. And that's where MOXIE comes in.
So the way MOXIE does it is with a simple chemical reaction that takes that carbon dioxide and separates it into 2 other gases, carbon monoxide, which is the stuff we don't want in our basements, and oxygen, which is the stuff we want to breathe.
So how does MOXIE work? MOXIE draws in this carbon dioxide from the Martian atmosphere and compresses it before passing it into what's known as the solid oxide electrolyzer, or SOXY. Yes, the MOXIE has a SOXY. It sounds like a children's book, but stay with me. Think of it like this. Carbon dioxide, CO2, is made up of 2 oxygen atoms and 1 carbon atom. The SOXY essentially separates the oxygen out from the carbon dioxide molecule. Those separated oxygen ions join up to create a new molecule, O2, which is the oxygen that us humans know and love. The gas left behind, the CO, is carbon monoxide, which is essentially waste. But on the plus side, it could also be used as fuel, potentially powering future vehicles on Mars. This separation process requires a lot of energy and temperatures of 800 degrees Celsius or 1500 degrees Fahrenheit. Now, the Perseverance rover only has 110 watts of power to share across all of its instruments, which is why in this first trial run, MOXIE only created about 5 grams of oxygen. But that begs the question, how much does an astronaut actually need to survive?
In kind of normal activity, we might use 20 or 30 grams of oxygen. So another way to say that is keep us alive and happy and active for 10 minutes. It's not a lot. That's what we make in one day's operation. So we have a long way to go from keeping, one person alive for 10 minutes to providing all the oxygen for a human base and an ascent rocket. But this is the first, and one small breath for a human, right? One giant leap for humankind.
All that heat and energy to create oxygen might seem like a lot of work, but according to Hecht, it's a lot better than the alternative, which involves launching and transporting oxygen from here on Earth. And if we learn anything from Mark Watney and The Martian, it's that surviving on Mars is a numbers game. In addition to food, a group of 4 astronauts would need 1 metric ton of oxygen between them to survive on the Red Planet for a year. But that's just part of the story. To launch a rocket off Mars to come back to Earth, those astronauts would need 7 metric tons of rocket fuel and 25 tons of oxygen. Taking all that oxygen to Mars would be hugely expensive, so it's much better for us to try and make it there rather than trying to BYO. Future missions to Mars would also need a much bigger version of MOXIE, with the power to create tons of oxygen rather than just a few grams. But while this little MOXIE can't make enough O2 to sustain an entire civilization, It's an important first step for helping to establish humans on Mars. Once you start to factor in other in situ resources, like water in Martian ice and the hydrogen found in that water, then suddenly you have the building blocks to do so much more. This won't be a solution to making an entire planet habitable. To do that, Hecht says we need to start thinking about trees, forests, even capturing more heat from the sun to melt Mars's polar ice caps. But for the first human missions to Mars, we now know that we can create one of the essentials for sustaining human life, and that is a pretty exciting first step.